Alright, so per Ostrovsky's theorem, published in 1916, the p-Adic absolute value over the rationals Q, that's going to be completely irrelevant. I'm never going to reinvoke Q. I'm just going to say rationals. Anyway, is found by the fact that any non-zero rational x, I'll come back to the parenthetical, can be written uniquely as x equals p to the n times a on b, where p is prime, a, b, and p are coprime, and a, b, p, and n are all integers. From this, it's concluded that the absolute value of x with respect to p is 1 on the quantity p to the n power. Okay, returning to the parenthetical. The p-Adic absolute value over the rationals is found by the fact that any non-zero rational x, note that, as usual, we're required to specify that 0 doesn't count. But somehow this isn't a red flag for anyone. This is going to come back. Okay, now, note that the case when x is 0 is specifically avoided. But somehow it's alleged that it's been defined, that 0, its absolute value with respect to p is 0. Alright, the absolute value of 0 with respect to p is supposed to be 0. Okay. Allegedly that's been defined. No, it isn't, actually. The proof, if you actually look at the proof, it also avoids dealing with x equals 0 by asserting that the absolute value of 0 is trivial, and thus we only deal with x greater than 0. That's in the proof. The proof does that's the move that the proof makes. It's like, oh, this is trivial, we don't need to consider this. So as such, it's neither actually defined nor demonstrated what 0's absolute value with respect to p should be. It's just axiomatically asserted. And it doesn't fit into the pattern at all. Alright, so here's some examples of some using this. Okay, so just 1 in base 7 is, its absolute value is 1. Okay, 1 in like any integer base. Its absolute value is 1. That's fine. Here's 7 expressed in base 7, and its absolute value... Or, wait. What the f... That's wrong. There we go. That's from earlier copy and paste of this one down here. Alright, so here we have the notation. Right, so this sequence of digits in base 7 has this value. Or like, right. That same sequence in base 7 has this p-Adic absolute value. Right, here's... So it's 1, because 7 to 0 is 1. Okay. And here we have 7 represented in base 7. Its value is 7. Its absolute value is 1/7. Its p-Adic absolute value is 1/7. Here we got 49 written in base 7. And here the p-Adic absolute value is 1 on 49. Okay. So that all agrees with this. Okay. So the absolute values which 7 Adic numbers can have are... It continues up to infinity. Infinite values. There's powers of 7, right? So 343, 49, 7, 1, 1/7, 1/49, 1 on 343, etc. Okay. Also note that these are specifically only absolute values over the rationals. And what's actually being given here is the order of magnitude of the absolute values, not absolute values themselves. Okay. The orders of these, yes, I agree with. And these specific ones, okay, I have no problem with that. Consider the following, however. So if we change the value, right, at that level, so here, the absolute value of 1 in base 7 is 1. The absolute value of 2, the p-Adic absolute value of 2 in base 7 is 1. The absolute value of 3 in base 7 is 1. 4 is 1. 5 is 1. 6 is 1. 7 is suddenly 1/7. Again, copy paste. So it actually won't matter. On these ones, it's not going to change anything because it's 1 on 1 is 1. But yeah, imagine I correctly, where the hell is my cursor going? Imagine I correctly did all of those. Alright, so it's supposed to be like this. And all the other ones. I'm not going to do them all right now. You can see the point. Anyway, and then so 8 is 1 again. 9 is 1 again. 10 is 1 again. 11 is 1. 12 is 1. Right? Huh. But now, isn't 6 closer to 7 than 1 is? And isn't it also on the other side of 7 compared to 8? So why is... Okay, so this is a separate question now. Why is an infinite repeating sequence of zeros to the left? Why is its absolute value 0? So this returns to, why did we just ignore 0? And shouldn't this be because of the limit of 1 with infinite number of zeros to the other side? So this is strings of digits, right? 1 with infinite zeros to the right. Shouldn't its p-Adic absolute value be 0? So this isn't like 1 point of zeros forever. This is 1, infinitely far out. At absolute infinity, we have a 1. And then everything between it and the decimal point is a 0. There's an infinite string of zeros in there. The limit of that isn't that 0? Can't we tie that in? But we haven't tied that in. It's just... Okay. But, okay, it gets a little more nuanced now, because in reality, that 1 with an infinite number of zeros after it before we get to the decimal point, that is the infinitesimal unit, which is not rational. So we should be confident in our ability to extend p-Adic absolute values beyond rationals in the general case, unless we want to have the definitions of of these things be completely inexplicable, as they currently are under the given definition and proof. And I think I meant this. I'm not sure. Okay, now, isn't it the case that if we have infinite zeros to the left and then a 1, and we're considering this in base 7, that it's 1 because those infinite zeros in base 7 gives us 0, and this part here gives us 1, so 0 plus 1 is 1, right? Or is this a place where we're ignoring the basic arithmetic that was defined by St. Peano? Right? Isn't that part of why this works? Anyway, okay. Another issue becomes apparent when we consider something like 21 with respect to its p-Adic absolute value. Now, 21 with respect to 3 is a third, but 21 with respect to 7 is 1/7. So specifically what I did here is I took two prime numbers and just multiplied them together. I'm like, okay, so with respect to both of them, it's just going to be 1 over whichever one we choose. It's going to be the inverse of whichever one we choose, because this number is just the composite of two prime numbers. So its p-Adic absolute values are going to be just the inverses of whichever of those ones we choose. Or if we choose 5, it's going to be 1. Which is stupid. Okay, so clearly 1/3 is not 1/7. Unless, again, we're ignoring the axioms set forth by St. Peano, where we have the axioms of identity and equivalence. The proof concerning p-Adic absolute values claims that the p-Adic absolute value is unique. So this is concerning. I actually don't understand half of what the proof is even trying to do when I read it. It's very similar to Dedekin's proof about Dedekind completeness, where like Okay, you're saying a bunch of shit, but it doesn't seem to matter? Why are you saying these things? These just doesn't go anywhere. Anyway, I will read it more carefully, but for the most part, I'm not convinced that it even makes sense. Now, 21 in base 7 is going to be 3, the digit 30, so 30 in base 7 is 21. Now, the p-Adic absolute value of that is 1/7. The 7-Adic absolute value is 1/7. 21 in base 3 is, interestingly enough, it's 210. 210's absolute value is 1/3. Right? These are both it's both the same value. It's 21. It's 21. Right? So what happens if we consider the other parts of these values? Right? So 100 in base 7 has an absolute value of 1/49. Okay. So 3, 0 absolute value with respect to 7 must be between 1/7 and 1/49 for things to make sense. Okay. 1 with 3 zeros after it in base 3, its p-Adic value is 1/27 because that's 3 cubed. So 210 in base 3, its p-Adic absolute value must be greater than 1/27. But since 1/7 is already much smaller than 1/3, we can just ignore the result of 1/3 outright. Right? It's not contributing. It's not helping us narrow things down. So we already have the biggest it could be is it's got to be between 1/7 and 1/27. This is the smallest it can be. When we're looking at just 7, it could be between here, but we've already constrained it with the 3 being in there. It's got to be there. Now, what if we just stop being morons for a second and we look at the 21 Adic absolute value of 21? Wouldn't that just be 1/21st right here? Right? Because it should be independent of the chosen base, and it must fall between these two values, and 1/21st does. Neither of the solutions that are given can possibly be correct, so why don't we just stop being idiots and be like, well, what if we just read this number as the number that it is? And we just recognize that what we're doing, we're just taking 1 over that number. That is the actual absolute value of this fucking thing. So we can just read the base 7 value as if it's a base 7 value, and the base 3 value as if it's a base 3 value, so that 30 in base 7 is proportional to 1/7, sure, but it's actually equivalent to 1 on the quantity 3 times 7 to the first power plus 0 times 7 to the 0 power, which is 21. And 210 absolute value in 3-Adic is proportional to 1/3. This is true, but it's actually equivalent to 1 on the quantity, 2 times 3 squared plus 1 times 3 to the first plus 0 times 3 to the 0. We just read the fucking number, and that's what its actual absolute value is. Why is this hard? And now, the goddamn... it looks like the rational numbers. It's just the inverse. You can plot this shit on a number line now, and it's not mysterious and random between like, let's look at this in 5-Adic and let's look at this in 7-Adic, and we get totally, completely, absolutely different fucking values. Why? Why? Especially since your explanation for why is the absolute value of 0 in p-Adic 0 isn't an explanation, but when we extend things this way, it makes sense. It actually makes sense. And we can follow the rules laid out by Saint Piano, Saint Giuseppe Piano. We can follow his shit much more honestly. Sometimes the shit that he said works. Sometimes the shit that he said works. So it's weird here, where it should be working, we're throwing it out, but then we're taking it as axioms everywhere else. What the hell is this nonsense? How is everything this broken? It's not this hard. What are we doing? What the hell are we doing? What? Like I said in the last video, this feels like it's laying out like the p-Adic integers. Something like that. Like, I'm gonna actually just fix this file right now, because why the hell not? Like, yeah, if you follow all of what's actually going on, what I'm saying here makes way the hell more sense than the canon, which is like, oh, it's just, you have to think about absolute value in a totally different way, and nobody can explain what that way is because it doesn't actually make sense, and the proof doesn't make sense. If you look at the proof, like, it's like a half-formed thought. Like, okay, you kind of got to something, but you didn't really finish the thought. Right? Because, I mean, basically the observation with the p-Adics is, like, say we've got, we're just taking powers of stuff, right? And the last digits of the values that we get, alright, so we're just taking integer powers of, so, like, 7. Sure, let's do it in 7. That's how you get here. So what we're doing is we're looking at powers of 7, and as you go further and further out, as you get to larger powers of 7, the string of digits towards the end starts looking the same, right? So you get this chunk of the value that is the same as the exponent right before it. If you divide it by 7, it doesn't change any of those digits. If you multiply it by 7, it doesn't change any of those digits, right? Or whatever your base is. That's the observation, but the thing that I think is missed is that the other digits aren't just random noise. The other digits aren't just trash that you throw away. If you ignore it and treat it as random noise, then you're not getting the full picture of what the hell's going on. And when you include them, oh my god, it just becomes so simple. The p-Adic absolute value of 21 is just 1 over 21. The p-Adic, and in all bases, the p-Adic absolute value of 417 is 1 over 417 in all bases. All of them. Just all of them. Oh my god. And then if you want to find the order of magnitude that is with respect to whatever chosen base you have, that is a separate thing. Okay? So if we want to, like the classical 7-Adic absolute value of 417, you can still do that. Just recognize that that's a separate observation, or a separate operation, a separate something. I lost whatever the hell I was saying. It is distinct from the actual p-Adic absolute value. The absolute value, it's not even p-Adic anymore, because it's not dependent on your base. So yeah, the whole idea of a p-Adic absolute value, it's like this half-formed thought where two observations merged together and they need to be separated. There is this other kind of absolute value that is occurring, and there is this thing that is occurring with respect to different bases. This is true. Both of these are true, but they're independent partially. They're related to each other, but they're independent of each other. Sweet Christmas. What is going on? I guess here, like, we kind of have a little bit of a... This is better than how the whole concept of binary operations is, right? Because so, if you look at the history of things, matrix multiplication is defined in 1812. Addition, or subtraction isn't actually correctly defined until 1830. Notice that both of these occurred after the Louisiana Purchase. So, matrix multiplication, in order to do matrix multiplication, the two things you're multiplying together are just fundamentally different from each other, the way that they're operating. So it looks like, okay, we have this multiplier, and what it does is it takes two completely different kinds of things. So it's a binary operator. That's reasonable. The problem is, once subtraction was figured out, nobody ever reanalyzed this binary operator idea. We just carried on with it, and we're like, oh, subtraction is a binary operator, addition is a binary operator, multiplication is a binary operator. Everyone went with that, right? And this is specifically laid out by George Peacock in 1830 in his treatise of algebra. He just straight up writes it that way, pretty much, and logicism picks up his ideas and just takes it, and nobody's dropped it. Nobody's reanalyzed it and been like, wait, these are all batch functions. There are no binary operations that are occurring. These are all batch functions. What the hell are we talking about with these binary operators being the fundamental thing that we're defining? There are no actual binary operators. Everything is a batch function. What the fuck? But that goes back 200 years from now. This, at least, it's only about a century old. So this being fucked up, I mean, you kind of found like a whole nother way to analyze the size of numbers, and you only did it 100 years ago, and you almost got it right. So, like, I actually have more respect for this than the like, how many thousands of years were people doing math and they couldn't figure out how subtraction worked? Seriously? Seriously? Anyway, yeah. But yeah, it does seem a little bit fucked up to me that people who like talk about this, they're like, oh yeah, well, it's been proven. Ostrovsky proved that this is the only other way that you could define absolute values. Except it isn't, because guess what I just did? I guess it's not different, but it's more complete. But, like, they have their head up their own ass so far. Like, they think that they're smarter than everyone else in the world. And they're like, oh, this is a natural thing that just falls out of numbers. But nobody saw it before 100 years ago. That's a dick argument right there. Why? Why are you such an asshole? Right? Like, I'm here criticizing this because the people that tout this as like, this is the gospel truth, they're dicks. Right? They're jackasses for their attitude about this. So they deserve to have the the air let out of their balloon, their sails, whatever the hell the words are. Yeah, I'm not sitting here saying that I'm smarter than everybody else. That's not what's happening. I'm just like, excuse me, this makes no fucking sense what you said. Also, you just you casually leave out, like, oh, this is over all of the rationals except 0. What? Why are you casually leaving out 0? You define 0 as a rational number, and then you never fucking use it as a rational number, right? The rationals are closed under division, because if you insist on including 0, then you're just being ridiculous. You're the one who defined 0 as a rational. You said 0 is rational, and now you're saying that rationals are closed under division, but we can't use 0 as the denominator. What the fuck are you talking about? And here, well, the p-Adic absolute value over the rationals works this way, except when it's 0. And we're just going to ignore that one because it's the trivial case, quote unquote. What the hell are you talking about, you crazy motherfuckers? No, this is gibberish. You're not rigorous. What the fuck are you doing? Jesus Christ.